today we're going to be focusing on application of the computational thinking. So we're going to be using computational thinking today, especially in the next session, the second session that we're going to have today. As you may know, we have two sessions today, so it's going to be a total of 6 hours together with me. So hopefully you don't get bored of my voice too much, but in the second session, I won't be speaking too much because mostly you're going to be solving the problems in groups. That's what I have planned. And in the first hour, we're going to be speaking about pseudocodes and flowcharts. So two different tools that is going to help you formulate your solutions and basically write it down on a paper or on somewhere, basically. So let me make sure that everybody's muted. Okay, there you go. So yeah, can you share the code for periodic? Yeah, so that was the answer, I guess. I hope you heard it, Yazda. Okay, so before we start, how many of you have completed the pre-class? So it was about pseudocodes and flowcharts, and also the riddles and problems, I guess. So first we will start with pseudocode, which is one way of writing down your algorithm into a piece of paper, your computer, etc. But it is for it is not for the computer to run it. So pseudocode, computer cannot understand it nor run it, but it is to basically explain your problem either to yourself so that you can understand it later and remember it later, or show it to somebody else. You want to show your algorithm to somebody else. You don't want to write it down in code yet because you don't think that it is perfect yet. It is just an idea for now, and you just want to share that idea with one of your friends. And in that case, you just write down your algorithm. You reflect it to the paper in the format of pseudocode, and then you can show that pseudocode to your friend. So that's what pseudocode is used for, and also for flowchart. This is pretty much the same, but flowchart is more created with using shapes, arrows. It is basically a diagram. You create a diagram there. But in the pseudocode, it's plain English. It's really close to plain English language. You write words, there are lines, and etc. And that's how you explain your solution in there. And we will get into the details of those throughout the next couple hours. Also, at the end, we will be solving riddles and problems in groups, and there hopefully you will be applying all of these. Okay, so before we start, let me ask you on your own words again. There's no peer deck, guys, today because there are no interactive questions in this slide right here. So I haven't started the peer deck. I only opened it and so I'm sharing my screen. You can follow it from there. Okay, so what are your opinions on pseudocode? What did you understand of it? Those who have completed the pre-class or have prior knowledge to what this means. Roadmap to solve a problem. So it's kind of like a tool which you can create a roadmap using, right? Yeah, it is like algorithm. It is not actually an algorithm itself, but it is a way of representing an algorithm, right? It is a way of representing an algorithm. You can say that. You want it. That's right. Plan and explain the source line by line. Source, you mean solution, I guess, right? Yeah, that's pretty much correct. Yeah, you basically, it's not kind of like explaining it in paragraphs and in the details and complicated language-related stuff with grammar and etc. With complicated, complex grammar and etc. But it has its own grammar and simple way of representing a solution line by line. So when you say it like explain the solution line by line, it's like writing it in paragraphs. You can also explain your solution in paragraphs by writing it down. But that's closer to literature, and that's too expressive. If that's right, if that's the right way to put it down. We want it to be as simple as possible and as less complex as possible, so that the person that we're showing it to can understand it. Informal way of programming, yes, that's a good way to put it, because in programming there are a lot of strict rules, right? If you don't follow even a small chunk of those rules, it will fail and the program won't run, basically. But in here, there are no such limitages, because the thing that you're going to show it to is going to be a person, not a computer. So they're probably going to be able to understand what you're trying to say in there. So it is an informal language for programming. So yeah, that makes a lot of sense. Detailed solution for a problem. Explaining your solution for a problem, yes. Human readable program, yeah. Also, when you say human readable program, so it rather than that, you should say that it is not readable by a computer. A program that is not readable by a computer would be more correct, I guess, because also a program that would have been executed by a computer should also be human readable. That's something we want, right? We want it to be clean and readable and etc. But in this case, it is the opposite of it. I mean, it's not the opposite of it, but this time the humans can understand it, but the computer has not anything to do with the pseudocode, because we write it for humans. Okay, so that's been a good discussion. Thank you for your ideas, and we are pretty much on to what pseudocode is, together with your contribution. Okay, so before we get into understanding what these are, these pseudocode and flowchart, etc., we have to understand algorithms, right? Because we said that to be able to express an algorithm or represent an algorithm, we're going to be using pseudocode and flowchart. And for that, we have to understand what an algorithm is. Actually, we have spoken about this in the last session. We said that an algorithm is a set of instructions to complete something, basically, complete a solution, complete something in most basic terms. And also here, we say, yeah, algorithm has a flow, so it has sequences, it flows, it iterates, it selects stuff, and etc. So we're going to be trying to express stuff like this with our pseudocode. So we're going to try to express a flow, a sequence, a set of selections and iteration, and etc. And here we have a definition, some rather more formal definitions of pseudocode. So let's quickly read through those so that we have further understanding of it. And right after that, we will be starting to see what it looks like. Pseudocodes are one of two popular ways to represent an algorithm. So one of them is flowchart and the other one is pseudocode. Pseudocode is an informal way of representing a computer program or an algorithm. One of you have already put that down in the chat, and we've discussed about it a lot, actually. It looks like a programming language, though it should be written in a programming language for it to be executed. It's language agnostic. So what does this mean? It is not for computers. The algorithm, the meaning of it is for computers, but the computer is not going to be able to understand that meaning in that format. So after writing down it in pseudocode in this simple, basic, plain English-like language, you have to convert that into an actual programming language. No matter what it is, you have to convert it to one of the programming languages. Writing pseudocode is basically writing what you want your program to do in English. And this is basically the stuff that we have discussed so far, right? So whatever you want your program to do, you explain that in English, but that English that you explain it in is not that complex and that detailed. It's not like a passage or like a story or something like that. It's really simple, basic. It is programming language-like, but it's also English-like. So it's somewhere right in between. And as the last bullet point, we have aims to mimic the general style of programming language. So this is what makes it different from writing a passage, for example, or writing a long story or anything like that. It has to look like a programming language also. look, I'm talking about the look of it, or also the function of it. That already has to be like a programming language. It has to have some logic behind it. But other than that, also its look has to be like programming language. Its format has to be looking like programming language, so that later on you won't have any problems when you're trying to convert it into an actual programming language, because otherwise it wouldn't have any meaning. And yeah, we have an example of pseudocode in here. Before I go through that, any questions so far on pseudocode? So Remisa said it is like a script. Script also is written in programming language, Remisa, but you can represent a script in pseudocode. That would be possible. Jalil has a definition for algorithm, and that's pretty accurate. Sequence of clearly defined steps. So we're going to be representing sequence of clearly defined steps using pseudocode. Okay, I guess there are no other questions. Let's read through this pseudocode right here all together. So in the first line, as you can see, it says output, what is your name? So what would you understand off of this? You haven't seen any examples of pseudocode yet. I mean, outside of this class, I don't know. But right now, you haven't seen any. And this is the first pseudocode that you see. What would you understand in that case? Output, what is your name? What is this out to do? This line of pseudocode right here. Output, what is your name? I mean, this is pretty straightforward, right? What is what you do expect this to do? Yeah, it's pretty much like print in Python, right? Or you can say that it's you expect it to be shown in the screen by the program. That's what you would expect out of this. There's a code that wants user to put user's username. Okay, that's the second line. We're coming to that. But the first line right here, output, what is your name? What you would expect out of that is what is your name prompted in the screen, or somehow it is going to be shown to the user, right? That's what you would expect it to do. And then we have this input keyword right here, and then it says user inputs their name. And this basically tells the computer or the person to take an input, right? And yeah, that's the code that Ayşe just put down in the chat. That's the Python representation of the second line, exactly. Second and first line, in fact. Yeah, good. And then you have store. So this is a little different. Maybe, no, this is actually not different. You also have this in Python. What would be the equivalent of this? In fact, Ayşe has put down also this one, right? Because this says store the user's input in the name variable. So there's a name variable. So the input that you take in here with the prompt, what is your name? Save that into name. So that's the name gets input, what is your name? That's what it does, what it's going to do in here. And then you output hello plus the name that you just got from there. And then output something else again, input something else, store that. And then you have some if-else statements in here. Again, you already know about that. A couple of if-else statements you have in here. And also that's quite obvious, right? There's going to be an if statement in here that'll be checking what happens. That will be checking if this is correct or not. And if that is correct, this will happen. If that is not correct, this right here will happen. And what is those happenings? Those are some outputs. You are aged to perfection. You're a spring chicken. Okay. So they haven't missed anything. Okay. So if you have noticed in the example, so let me go back again there. So if you have noticed here, we have some plain language. So this is a lot of plain language, by the way, in this example right here, so that you can understand it straight away. I chose an example that had a lot of plain English in it. But normally, for example, here, store the user's input in the name variable. This is too long and too expressive and too detailed and too close to literature, again, or close to a story like text. But we don't want this normally. So the better version of this would be store input to name, for example. This would be better. Store the input, an arrow, name. Maybe that would be better. I don't know. But other than that, the plain, other than the plain English part, if you have noticed, we had all these keywords, right? So those are the actual stuff that mean something in terms of an algorithm or in terms of programming here. The keywords are crucial. So in pseudocode, we have these keywords so that you can represent programming related stuff. For example, what are those? These are stuff that you would also encounter a lot in programming languages and programming environments. For example, you might want to indicate the beginning of the program. So in the beginning, you say begin and then write your code down there. In Python, you don't have this, but in, for example, Java or C++, you would have to indicate a main function, for example, and that main function is the beginning of the execution of the program in that case. So this is something that you encounter also in programming languages. In input, you do this a lot in Python. I know that. And with this, basically, you take an input. And this is another keyword that you would want to use in your pseudocode when you want to indicate that at that point, you want the computer or the algorithm to take an input. You have read, get, and this is used when reading data from a data file. Also, this is something you can do with Python. Instead of getting the input or information from the user's keyboard input, you can also get it from a file. In that case, you can use the keyword read, get. Also, at this point, I have to mention this. Here I'm using these keywords, and here I'm using input for reading from file. I'm using read, get, etc. But these are not strict, or these are not determined by an institution or something like that. But the only thing that you have to be careful about here is that they shouldn't be vague, and everybody has to be able to understand the same thing in here. So there are some popular keywords that people prefer, such as input, for example. What would you replace that with? Input is input, right? You wouldn't replace that. So there are some popular words that people prefer to use. But other than that, for example, instead of read here, you can use, I don't know, for being more expressive and more clear, you can use read from file, for example. Okay, that's also okay. So these are not strictly defined rules or anything like that. Okay, you can be as flexible as to the point where it gets vague and it gets more complicated. You don't want to do that, but other than that, you can be as flexible as it is okay. Any questions so far? Nope. Okay. So let's continue reading the keywords. In a couple of minutes, you're going to be writing your own pseudocode. So I'm just trying to get you familiar with what kind of keywords you're going to need. And then you'll decide on your keywords on your own. I mean, the words, you'll decide on them on your own, but their functionalities will also be one of these in here. You have print, display, show, output. Again, it's quite obvious what these mean. Basically, show, prompt, put in the screen whatever is indicated. These mean compute, calculate. So whenever you want to calculate the result of a mathematical expression, you can use compute, calculate. You also may not use this. Just put the mathematical operation in there, put the expression in there, and then people will understand that it is going to be calculated. But also you might also want to indicate it. That's also okay. Set, initiate, to initialize values. So in Python, for example, when you say name1 gets, I don't know, Alex, that's basically initializing a neo variable and a value. In that case, you might want to use the keyword set and initialize, set or initialize, or any other word like this. We have increment, bump. Using this keyword, you can indicate that a variable's value is going to be incremented by 1. You can use decrement, the exact opposite of that, and then at the end, you'll have to indicate that the program has ended. Okay, so these are our keywords. Let's now have an exercise in here. And it says, let's brew a tea. Think that we have all the ingredients, tools, etc. You don't have to use keywords on this exercise. So you're completely free in this exercise. There's no strict rules. Just put down the pseudocode for brewing tea. All the ingredients and tools are ready. Just you're at the table and you have to brew it. Just write down a pseudocode that brews it. But also here it says you don't have to use keywords in this exercise, but the lines are important, right? So you have to be strict with lines. So please put your instructions on each line, okay? That's important. Go back. Victoria, today we don't have a peer deck because there are not many interactive questions in here. In fact, we have these questions, but it's okay to put down the answers of these in the chat. And right now I'm asking from you to write down a pseudocode, which is the algorithm to brew a tea. Okay, Hikam, but this does not look like a pseudocode, right? This looks like a receipt and not a pseudocode. So try to make it look like a pseudocode, okay? And in that case, the lines are important, and also you shouldn't have the bullet points. That's especially what makes it not look like a pseudocode. Because the problem with that, by the way, why you don't have the line numbers in a pseudocode, because actually these are not line numbers, but rather they are instruction numbers, right? Why you don't have them? Because you're going to have loops in your pseudocode, and in the case of loop, for example, a step is going to be repeated a lot of times, and at that point, maybe the instruction numbers might create some problems. But other than that, Hikam's solution is pretty much the right solution. But I am expecting a couple more answers. Also, the reason I say you don't have to use keywords in here is because this is not something to be executed by a computer, right? So, for example, the word input might not make sense in the context of brewing a tea. But in the upcoming examples, we will have some heavily computer-related examples. Begin, boil water. Okay, you use the keywords, that's also okay. Begin, boil, so you say begin in the beginning, and then you say boil the water as a second instruction, so that should be under begin. Boil water should be under begin. And then you say input 2 cups of water. So what you're trying to say there basically is boil 2 cups of water, I guess, right? And then the output will be tea, you say, but you forgot about the tea part, right? You also have to add some tea to your boiling water. Begin, input cup of boiling water, okay, input tea bag, okay. Result, mix water in tea bag, results, drink tea. Okay, yeah. That makes sense. And that seems like the correct answer. Okay, so I have another example in here, which is with keywords this time. Okay, we have another example. Let me read through that quickly before I jump into this. Begin, put tea bag in mug, add hot water, add honey or sugar. Again, this also, you have to write it line by line. Okay, that's the only problem. I mean, the format has to look like a pseudocode. That's the only thing about it. Okay, Yusuf's example is more formal and closer to a programming language. Let's also go through that. And in the next examples, we will be seeing answers like these more often. Show, let's brew a tea together. What type of tea you like? Input, user enter tea type, store, tea type, algorithm, tea instructions, output, your tea is ready. Okay, so the tea instructions, you're kind of like using a function in here, right? So the tea instructions are the instructions that were created by the other students. So you're just pasting that right there, and you have created a tea machine in here. Okay, that's also good. Another example by Divine. Begin. After beginning, you boil the water, so that's one line below. Input 2 cups of water, input 1 teaspoon of sugar, tea bag, and then the output will be a tea. Yeah, also that makes sense. Okay, let's now get into more examples that require these keywords and that are more related to a computer. And here we were trying to give instructions to a human, so the stuff that we wrote down were like more human-like, and we didn't really need that much of keywords, except you use them, but that's also okay. But we did not need them. You could have also said, in fact, some of you have said, for example, Hickham's example had no keywords at all, almost, and that also explained this stuff. But when it's more computer related, the algorithm is more mathematical and is a more mathematical and logical thing, you will need those inputs. For example, in here we have a kind of like a mathematical problem in here. And we will be writing the pseudocode for this right here. And we will be calculating Mary's wage. So in the beginning, you will have the information about Mary's hourly pay. And later on, after knowing about the hourly pay, you're asked to calculate her total pay. And in here we have the answer for that. This is the, again, as I mentioned, mathematically intense and more logical example in here. So you can see a lot more keywords. So let's read through it together. So the program begins. You take the how many hours he works, input of that. You take the input of his hourly rate, so how much is he paid hourly, and then to be able to calculate the total pay, his daily wage, actually this is, and you basically multiply hours by rate, save that to pay. Here, for example, we are not using the word set. We are actually creating or initiating a variable called pay, but we're not using the word set, initialize, or anything like that. We're just setting it, and this is still quite expressive and it's clear, right? It's just creating a variable, and it is recording the value of hours times rate to that value. And at the end, it outputs, the program outputs that result that it gets from there. And then the program ends, okay? It is going to look something like this, the answers that you're going to be giving in the upcoming questions. Okay, so before we jump into those, we're going to see what if else and else if is and how they work, so that you can be able to use them in a pseudocode. But before that, we have a question from Sagar. Is there any limit for input that we take in a row? No, but but you have to clarify it to the person who's going to be reading it. You have to show that you're getting more than one input. So it is better that you do it in a couple of lines. It looks better, but you can also do it like this: input, hours, comma, rate, for example. That would also do, but the most clear and the one that is not going to be missed is going to be this one right here, the line by line version, okay? Because, for example, the person reads it, but he misses that you're getting two inputs right in there, and they don't see the comma. Later on, they might get confused, and etc. So this is the most clear and guaranteed one. Okay. Okay, so let's now see if, else if, and else. This is something you are actually seeing in Python, right? Did you do conditional statements in Python? Have you come to those? You haven't learned yet? Okay, then. That's good. Now you're going to see them. And then you're also going to be seeing them in Python, but before you see them in Python, right now you're going to be learning them logically. So that's really good. If, else if, and else, these keywords are used if a certain condition has to be met for the upcoming block to be executed. So you have a block of code, and you want it to be executed if something is true, something has happened, or something holds to be true. We have some examples in here. For example, if you're happy, then smile. If you're not happy, you just skip this, okay? Do whatever you want. Or we have another one. If you're tired, then rest. Else if you're stressed, then relax. Else, keep working. So if you're tired, you're going to do this. If you're not tired, you're going to come here and check if you're stressed. If you're stressed, you're going to relax, but also if you're not stressed, so you're not tired, you're not stressed, in that case, so if you're not both tired and stressed at the same time, in that case, keep working, okay? And for example, here you can add a loop this, and then just tell the person that they have to keep working if they're not tired or stressed. It sounds a little harsh, I don't know, but also it's good, I think. Yeah, it makes sense. As you can see, we also use indentation in order to declare that smile is being executed inside the if statement above it. So this is important because otherwise it won't be expressive and as clear as it should be. So the block that you want to be executed, if the condition is met, that has to be indented a little inside, like then smile in here, or like then rest in here, okay? Or then relax in here, and etc. So if this is true, the indented line will be executed. If this is true, the indented line below it, right below it, will be executed. And also the same goes for other conditions right here, for example, this one or this one. Okay. So these right here, if you're happy, if you're tired, if you're stressed, these are the stuff that you're checking, okay? These are the stuff that are either true or false. So these conditional statements take in values that are either true or false. This is important. So it has to be either true or false so that you can decide on whether the block underneath it is going to be executed or not. Okay, so again, you have the being happy case in here. If that is the case, then smile, you execute the smile. So this is the thing that you execute. And on the other examples, you have tired, stressed, and etc. And those are the values that either are true or false. And the stuff that are under them are some executions. Whatever you want to execute under that, you can create a new value, you can do a mathematical operation in the context of programming I'm speaking. You can do whatever you want to do in there underneath them. Okay, this keyword is used if a certain condition has to be met for the upcoming block to be executed. So this is the if statement again. If you are happy, it is the if keyword. It checks if you're happy. If the answer to this is yes, so if this is true, then smile. If the answer to this is no, then the if ends, okay? You have to use the word end if to declare that the if block has ended, all right? So there's a question in the chat, why not rest? Which part are you asking, UI?
You see, if you are tired, then rest. Why didn't you highlight rest as one of the keywords?
Oh yeah, also rest and relax are keywords in here, yeah. Rest, relax, and keep working are keywords, that's right. Just like smile, so that's blue. Yeah, that's
okay. Thank you.
But again, here the smile is the blue one in there. So it is something to be executed if the condition is correct. So we have an example in here. Let's read through it all together and see what is this going to do. Also, I might ask the output of this from you guys. So please read through it and try to put the output in the chat as a final result. So the code begins. We take two inputs. As you can see, somebody asked, can I take a couple of inputs in a line? And the answer to that is yes, that's what is done in here. Input, those are hours and rates. So hourly rate is entered. How many hours the person works is entered, and then their hourly wage is entered. And we say if hours entered are less than 40, then pay gets hours time rate. So let's say hours are, let's say this is a weekly wage and the hours are 30, okay? The person works 30 hours a week and their hourly pay rate is, let's say, I don't know, $15, okay? So this is 10 and this is $15. Don't forget about that. So if hours are less than 40, what will happen in this case? Are hours less than 40? And what should happen if it is less than 40?
Hours multiplied by rate.
Yeah, that's
Yes.
it.
So if this is correct, it should go here. It should go here. And this is correct in our case because hours are 15 and 15 is less than 40. So it goes here. That's true. So pay gets hours times rate. That's correct. So what does pay become? Hours were 30 and rate is 15. What does pay become?
Output.
Excuse me? Yeah, 450, right? Somebody said in the chat. Pay becomes 450. We skip the else case because that would be executed if this were false. So that would be skipped. So the output will be 450. Good job. So let's do another example. This time hours are 50. Okay, hours are 50, and rate is $20. Okay, hours are 50 and rate is $20. In that case, what would be the output? 50, 20. Our output will be 50 times 20 plus 50 minus 40. So yeah, it should be 40 times 20. 40 times 20 plus 50 minus 40 times 20 times 1.5. So it's 1,100 if you have calculated it right. And that will be the output. So what happened in here? We had a condition that checked if something is true. If that were true, we executed this line right here. And if that were false, we executed the else block, which is right here. Okay, and that's how if and else statements work. Okay, this time, just a second. This is the same exercise. So I should just skip that. We will continue with loops, and then in the upcoming, after finishing the loops and whiles, we will have a couple more examples. Okay, we have 2 minutes, so let me also talk about loops a little bit, and right after that, we will continue with a break. We will do a 15 minutes break. So we have loops in programming and in creating algorithms as well. And as it says in the name, when you want something to be looped, so repeated a couple times, so more than one time, basically, you use loops for that purpose. And in most of the programming languages, we have two types of loops. One of them is a for loop, a for structure, and the other one is a while structure. Right now, we will see both of them. For structure is the one which iterates over list of elements. So it iterates something, repeats something for each element in a list, for example. Okay, so we have an example in here. Let's quickly go through that so that you can elaborate it a little more. It says for every day of the week, count. For example, the count function, code or whatever it is in here is repeated for each day of the week. Okay, so for one time it is called for Monday, for other time it is called for Tuesday and Wednesday, and etc. So it is called 7 times in here. What for structure enables in here is that it makes something to be run, something to be repeated for each element in a list. In this case, our list is days of the week, and the elements are days. And the thing to be repeated, the code block to be repeated in here is count. So what this will, there's no output in here, but what this will count up until is going to be 7, okay? Okay, so let's now go for a break. It's going to be a 15 minutes break. Right after we come back from that, we will continue with while structure. And then you'll hopefully understand it much better. We were talking about loops, and the first loop structure, so one of the two that we were about to talk about was for structure. Actually, we had some introduction to it. And what I said about it was that it is used when you want to do something repetitively over a list of something. So you have a list, or you have a interval, for example. So number of numbers in a list, for example, you can also have that. Or you can have an interval. So for each item in that interval, for each number in that interval, do something. So do something. This also can be weeks of the day. So this list also can be weeks of the day, for example. The list is the week, and the days in there are the items. So you can repeat something for each day of the week. Or it can be days of the month, days of the year, and etc. Or maybe you have, I don't know, you have some other list. I don't know. It can be anything. You can make a list off of. So if you want something to be repeated for the amount of items in that list, you use for structure. And here we had this example that I just mentioned for every day of the week. So for each day of the week, do something, and that do something is counted here. So this will count up until 7, and it will proceed like this. For this Tuesday, count 1. For Monday, count 1. For Tuesday, count 2. For Wednesday, count 3. This will loop, but this will loop really fast because probably it will be executed by a computer, etc. But in the context of the pseudocode, that's how it works. Okay. Once you read this, you understand that this block right here will be executed for each day of the week. Okay. Any questions on for structure? It is as simple as that. There's not much complication to it, but it's basically repeating something for each item in a list. Any questions? No questions? Okay. So we have the while structure, which is our other loop structure. And it is similar to the for loop because, again, you're looping over something, but it's different from the for loop. Instead of iterating for each element in a list, in an interval, and etc., it iterates until a condition is unsatisfied. Okay. So for example, let's check what does that mean. So there we have an apples variable in here that gets the value 5. We have oranges variable, which gets the value 10. And then we say, while apples are less than oranges, increase apples. So what will happen in this case? We will check. Are apples less than oranges? 5 is less than 10, so that is true. We go in, so this condition is satisfied. In this case, the condition is true, so it is satisfied. We go inside the loop, it says increase apples. So that probably means that make apples 6. Apples are 6 now. We come at end while, and we go back. Once we come back to end while, we go back again to check the condition. Apples are less than oranges. Yes, they are less than oranges. They're 6 and oranges are 10. Increase apples, it will be 7. We will go again, 7 to 10, increase apples. Apples are 8 now. 8 to 10, we go again, 9 to 10, we go again, 10 to 10 at this point. So after iterating 9 times, at this point, after iterating 5 times, the apples will become 10. And are apples less than oranges? No, they are the same. So we just end while and go outside of it. At that point, the condition right here is unsatisfied. Okay. Is it clear? Do you guys have any questions? All clear? Okay. Okay, great. So now we will have some examples that are going to ask you to write some pseudocodes using all of this stuff that we have just learned. So what you have learned so far? You have learned the keywords, which are the basic keywords that indicates stuff related to a computer would do. For example, such as taking an input, you indicate that with the keyword input. I don't know, do some mathematical expression, set a variable, or read some value from a file. All of these keywords, you have learned those. And these keywords, they're not strict. You already know about that. You can choose your own keywords as long as they mean what they have to mean. and you can choose your own keywords. But other than that, there are popular keywords that are used, so you can also use them. That is also completely all right. Secondly, you have learned if, else, and else if statements. In there is some condition. If that condition is met, the block right underneath it is executed. If that condition is unmet, the next else if it exists, is checked. The condition next to that is checked. If that is also correct, that is also incorrect, so that is also false, it will also go under that and check other else if statements if there are any. And at the very end, it will go to the else statement and then execute that if all the other ones are false. Okay, all the other if in the beginning if statement and the else if statements. After that, if all of them are false, it will go to the else statement. Okay, you learn those. And then finally, in the last couple of minutes, you have learned for structure and while structure, which are two more tools that we are going to use so that we can repeat something over and over again. In the case of for structure, we will be repeating it for each item in a list. And for the while structure, we will be repeating it until the condition that we declare is unsatisfied. Okay. Let's now see the first question right here. Write a pseudocode solution for below problems. Write a program which checks whether a given number is positive or negative, and then just give the output. So the program should also say negative or positive. Okay. And the input is not going to be 0. You can also see that. So write a pseudocode for this. I'm expecting your responses in the chat. Okay, so we got one response in the chat so far. I will also be waiting for the others, but let me go through this quickly because it looks good and it is accurate. Also, there are some minor stuff that you can improve about this solution right here. So enter number, that's perfect. So that means that I have to input a number. That's quite clear. If number is less than 0, that's also quite normal and clear and regular. And then right underneath that, if number is less than 0, right underneath that, you have then write negative. But that has to be indented a little bit, Jalil. That's important because by indenting it, you will be saying that that is the block of the above if statement. So you have to indent it a little bit. Also, the write positive, you have to indent that so that the person that reads it can understand that it is the block of the else statement. Okay, so indentation is important. Also in Python, it is important. In pseudocode also it is important because you don't want to use curly brackets and semicolons and etc. when writing with your hand. That's really painful. Okay, so Sajan says if number is less than 0, then negative, else positive. Yeah, you can use the words write, prompt, print, and etc. Next to negative and positive. Other than that, that's correct. Begin, input num. If number is greater than 0, return positive, else return negative. This is perfect, Asha. Good job. This is 100% perfect. Ramisa, input, enter a negative or positive number. That's your own way of doing it the first time. That's pretty good. That's pretty all right. And that's pretty clear. And I can understand what you mean in there. And then you say if number is greater than 0, print positive. Again, you have to indent the print positive and print negative. Other than that, again, it is completely fine. Okay, so I guess we're getting a couple more answers. After we get them, we will just proceed with the next question. Yeah, we got one more. After reading this, let me go to the next, skip to the next question. Yeah, two more actually. Write number, and then if number. So this is pretty much the same. Again, you have to indent print positive and print negative. Other than that, it's good. Good job. User says input, enter a number. You have a prompt for the input. That's good. And then you store that value inside the variable called numbr. That's also good. And then you check if numbr is less than 0. If that's the case, you output your number is negative. Else you output your number is positive. Again, indentation is important. Under the if blocks, you have to indent it. In case you don't get what I mean by indenting, let me show it to you quickly. This is Ramisa's example. You just have to hit tab before. Oh, so probably Slack does not allow you to do that. Is that why? No, it actually allows you. Okay. You have to do this. Okay. This is what indentation means. So this is the correct one. And this is the less correct one, let's say, because indentation makes it look better and it is easier to understand that one. So this is the wrong one. Okay. So I hope that's clear now. That was about the only mistake you guys made. A couple of you have made. Other than that, it was completely right, and I can see that you got the idea how to write the pseudocode. So that's perfect. Good job. All right, so let's continue with the next question. And it says, write an algorithm which prints true if letter C, so that's a capital C, exists in it and in an input and prints false otherwise. Let's see who can make this. So exist, what does that mean? You have to be careful about that. And then you have to check that. But beware. If C exists in blah, 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 that's a little bit of cheating. I would also count that, but there's a better way of checking this. The keyword is 1 by 1, or the keyword is for each, for example. We'll try to do that in that manner. Okay. Okay, so yeah, already a couple of you are doing if C exists in text, you're doing it in that manner. But try not to do that. Okay, this I also accept because in Python we have this. If C in text, we use that. But in some programming languages, it's not that simple. So the programming language is not that smart, and it does not understand what does existing means. So try to think in that manner. If you were a computer that does something, so computers do stuff 1 by 1, right? As humans, once we see the word, we can quickly detect that. We quickly detect if C is there or not. We can quickly understand that. But computers do not work in that manner. They have to do it 1 by 1. They do not have such perception. They do not even have any perception. So the keyword here is, as I said previously, it is 1 by 1. So in which structure do we have something? We have something that does something 1 by 1, or for each list, for each element in a list. Which structure would you use? And then how would you check if C exists in there in that manner? Think about it. I really wonder who can get the answer to this first. If it's not clear what I'm trying to say, you can ask, I can repeat that again. Okay, all of your answers are, again, in terms of Python, is correct, but I'm pretty much asking you to use. Yes, good job, Leila. That's perfect. So this is what I was expecting, basically. Let me see if I have skipped any one of you who had the same answer. Yeah, Leila got it. What I was trying to say. She said input text for CH in text. So what he basically does here is he goes through each letter in the word, in the input word, and checks if that particular letter is C or not, 1 by 1. Okay, she checks it. If she encounters C, she prints true, else she prints false. But the only problem with this code is that as soon as the first letter is not C, it will print false. Sorry, it will print false many times. So up until the end, it will say false, false, false. Once it encounters it will print true, and then false, false, false again. Okay, that's the only problem. We only want it to print true, but this is quite close. So good job. This is what I had expected. Good job. And how would you solve that? Can anybody solve that? In here, it prints a lot of falses and then a true once it encounters, or a couple trues every after it encounters C's, and then falses again. How would you fix this problem? We only want one false, or one true, or false at the end. I mean, if C exists, it should say true. If C does not exist, it should say false. With a break, you can do it, yeah, but with a break, you could do it, but how? I mean, breaking after what, for example? You can break after true, but do you have the previous falses again? You can break after false, that will break the whole thing, and that won't work. How would you do it? We can count C in the text. This is actually what you can do. So you are checking if you are encountering C. That's completely all right. So that's an if letter. That is basically if CH is C, you are checking that. And under that, you can do this. You can have a Boolean value at the beginning, at the top. You can have a Boolean value. So if you encounter with C, you can just switch that Boolean value to true. And after the loop ends, below the loop, you can just print that Boolean. This is one option you can go with. Okay. And other than that, the solutions that were without the for loop, those are also correct as I mentioned. Okay, so those also are correct. They make sense. The person who reads it understands what it does, but I wanted an extra just kind of like a challenge thing to do. So that's why I asked for that. Okay, good job. So let's continue with the third exercise we have. Write a program that takes a number as an input and prints true if it is greater than 10 and false otherwise. So this should be quick. You have already done this. I will skip it after we receive the first response. Let's see who gets the first response here. Okay, we got two answers. Begin, input numbers. If numbers are greater than if numbers is greater than 10, return true, else false, and that's it. Yeah, good job. So you got 3 people who got it. I'm pretty sure also others would be able to get it. This is similar to the 0 one, right? Now, instead of checking if it is greater than or less than 0, we're just checking if it's greater than or less than that. So good job. But that was the last example we had. Now we will continue with flowcharts. Okay, let's continue with flowcharts. And we will also have a couple of examples in there, which I will be solving because probably you won't be able to hand me out your hand-drawn figures, so I will solve it. Okay, so thank you for your participation in the exercise. Let's now continue with flowcharts. And of course, as always, I am asking you, what did you understand off of flowcharts, or what do you know about them prior to your this class, basically? Flowcharts. Even if you don't have any ideas about it, just try to predict what it means. Flow chart. So it's a chart that flows. What could it mean in the context of computational thinking? Diagram to solve the problem. Yeah, again, it is a diagram to represent the solution to a problem. Yes, that's what it is. That's a good definition. Yusuf says instructions pictured as diagrams. Yes, exactly. So it is basically, instead of letters this time, you have shapes and arrows, so diagrams, basically. More structured. Can you elaborate that a little bit more? What does that actually mean? More structured. So it has more clear rules. Is that what you mean? Strict rules, actually. Okay, yeah, that's correct. So you have these certain shapes and arrows and ways of putting those arrows and shapes down, and they are pretty strict, and you cannot add your own shapes or anything like that. So yeah, it is more structured compared to pseudocode. Exactly. A diagram that represents a set of instructions. Yep, correct. Graphics. Yeah, it is graphics that represent a solution. So that's also somewhat correct. Mina says it's an algorithm to solve a problem by using diagrams. So it is not the algorithm itself, but the flowchart is not an algorithm, but you represent your algorithm or any other algorithm out there by flowchart. So flowchart is the name of that representation. Arrow and diagrams to represent an algorithm. Exactly, that's the clear and basic and to the point definition of that. Good job. And we have standard symbols to represent different instructions. Correct. Represent a sequence of instructions. Yes, correct. With using shapes. If you say also, that's the exact definition of flowchart. So let's quickly read through the definitions that I have in my slides in here. A flowchart is a diagram that represents a sequence of instructions, which you can also say an algorithm. By the way, I'm shining too much. Let me open up the lights here. Yes, there you go. Okay, so a flowchart is a diagram that represents a sequence of instructions, which you can also say an algorithm. So you're basically representing an algorithm using these shapes, arrows, predefined shapes and arrows, which mean something in the context of algorithms, and you use them to represent this algorithm. Flowcharts have standard symbols to represent different instructions here, I also said, which basically means the same thing. Okay, what kind of shapes do we have here? These are about the only shapes that you're pretty much going to use for creating an algorithm, and they are enough. They are more than enough, in fact. Some of them, for example, this connector right here is not necessarily a shape, but it is something pretty straightforward. We will come to that. So as the initial shape, we have start or stop symbol. Start or stop symbol, that's pretty straightforward again. It indicates that your flowchart is starting there, okay? That's to indicate that. And also at the end, you have a stop indicator, which indicates that that is the end of the algorithm that you're representing. Then you have a process. So this is an instruction or a command. What could this be? For example, a mathematical operation, okay? Or this could be, I don't know, creating a new variable, okay? Creating a new list, or changing the value of a variable to another variable. So assignment, that we call, right? This could be any kind of operation that you do. This also, you can say that this is the blue marked square in the context of pseudocodes, if you remember. So we had a conditional statements, and the condition in there was marked in red. And under that, we had the blue part, which included then a process, an instruction. So the equivalent of that in here in flowcharts is this process box right here. We have decision, and this is the red marked part of the pseudocode. So this is where you have a condition, and depending on that condition, which is either yes or no, you go to either one of the either ways, and that's what this one does. There's a condition inside it. You just write it down inside this box right here, and then you have arrows going to the right and left. You'll see a big flowchart in a minute, so no worries. And then you have input and output box that looks like this one right here, where you take an input and then give an output if need be. You have a connector. This is used for if you have a really big flowchart. If you want to connect 2 points, if you want to show that 2 points are connected to each other, and the person who reads it has to continue from that point after that point, you use connectors. That's what connectors are. You can also do that with a really big arrow. That's another way you can do it. And then direction of flow, which is kind of like the skeleton of our flowchart. You basically connect all of these boxes together with these basic arrows. Okay, so we have an exercise in here. I will do this by annotation. Let me open it up. Am I drawing? Yes. So before I do it, you can also, if you have pen and paper or any environment where you can draw, you can do it. Or if there's any volunteers, I can just give them the pen if that is possible, and then they can draw. That's also okay. So let me see if I can do that. I'm not sure though. Yes, I can do that. But probably. Okay, so yeah, if we have any volunteers right now, they can draw on the screen. Do we have any volunteers which can draw a flow chart for this problem right here? So it's a flow chart that takes two numbers as input and increments and prints the number each time until it reaches the second number. So for example, the first input will be 2, the other one will 5. So the output of this should be 2, 3, 4. Okay, any volunteers to draw this flowchart on the screen right now? Come on, guys, I am expecting someone. Okay, you can do it, Yusuf. I guess you have the annotation right now. Can you draw it? Can you try, please? Can you click on the screen?
Would be better if you give me a share screen.
You want to share your screen? Okay, yeah, that's
Yeah.
Let me do it. Ulrich Mentor, can you please help me? Can you please give Yusuf share screen? I cannot do it. Unfortunately, I cannot do it. Ulrich Mentor, are you here? Could you please help us? Yeah, unfortunately, I cannot not share screen. Yeah, I cannot do it. Could you do it on my screen, Yusuf, by an annotation?
Actually, I was going to use a special program on my computer, which I have already got figures ready.
Okay, I see.
Because annotation is too difficult for me.
Okay then. Okay then. Then you can do this. Could you take a screenshot of your drawing?
Yeah, okay. I will complete it and give you a screenshot then.
Send it to the chat. Yeah, thank you. Okay. That's better. So Yusuf will be sending us the screenshot in the chat of his own drawing, and I will try to draw it here on screen. So let's wait for your response and then I will draw it. Probably I won't need to draw it after we receive your response. But we can go through what you will need in here. Hopefully also you guys are working on this, but I can mention what you're going to need to be able to draw this flowchart. So definitely you're going to need the input boxes, right? Let me go back here. It's this question, by the way, not this one. Okay, so input boxes are these. So this box right here, you will need that in the beginning. You will need two of them, in fact, or in one of them, you can also take two inputs. That's also okay. So it will be called number 1 and number 2. You will take two inputs. And after that, you will have a decision box, which compares number 1 to number 2. And there it will say decision if number 1 is bigger than number 2. Let me go back to the question. Takes two numbers and then increment and prints a number each time until it reaches the second number. So if the first number is less than the second number, we have to say decision 1 is yes. So in the case of yes, in the case when number 1 is less than number 2, increment number 1. So that is the process box where we increment it. Okay. Yes, then we go to process box with an arrow, and in there we say increment number 1 by 1, and then we go back to decision box. Okay, let's now draw it. And at the end, of course, we will, and each time we will also give an output. That's also important. After processing it, after incrementing it, just give an output of it. And then finally, when decision is no, so when number 1 is not less than number 2, which means it is either greater than or equal to number 2, just stop the process. So let me draw it here. Okay. So yes. So you'll start by an input. It will be like this. So I will say num1 and num2. Okay, this is where I get the input. Also, I have to initiate it, right? So let me initiate it right here. So this is the start. And then we have an arrow in between. And yes, Aisha has drawn one, so that's pretty good. And I won't have to draw it in here in annotation. That's much better. Let me actually show this one too. So let me check it quickly. So you say you take input. Can I rotate this actually?
I said input 1 and 2, and then count equal, and then process it to count equals 0.
Mm-hmm.
If num1 equal num2, yes, stop. Otherwise, no. Increment the count, and then num1 equal to num1 plus count, and then go back to if, check again, if num1 equal to num2.
Mm-hmm. Yeah, this looks like it is correct, but the only mistake that you made is that you don't actually need this count too, but what you have to do is increment the number 1. So you have to increment the number 1 and print number 1, not count. Other than that, it is completely correct. Good job. Okay, let me put it in the screen, but yeah, it is, yeah, I cannot rotate it, unfortunately. Which is the circle box. So it starts. So this should be inside it, actually, not next to it, but it should be inside it. So probably you did like that because you couldn't do that, right? It was technical limitages, I guess.
Yeah, it doesn't fit on my screen.
Okay, yeah, that's
the shape's becoming too big and doesn't fit.
Okay, yeah, that's not a problem. But normally this should be just inside that. So just be aware of that. And this is the starting point. You get 2 numbers here. So this will say number 1 and number 2 inside it. So it will be taking the inputs for those variables named number 1 and number 2. And then you will have a process in here, which will be incrementing number 1. But the thing is that actually you should have first put the decision box, because maybe number 1 and number 2 are already equal, right? So that might be a problem in here. If they're already equal, you should just go ahead and stop and do nothing. So these should change places. Other than that, it's okay. So if A equals B, if that's a no, just do A plus 1, and you will be repeating this up until it is while it is no. And as soon as it is a yes, if A is equal to B, just stop it. So what this will do, for example, in the case of oops, it went. Okay, it's back. So what it will do in the case of, for example, inputs 2 and 5, let's check that out. So let's start with 2. I am assuming that these switched places. So it will check if 2 equals 5. It will be a no. So it will go and process A plus 1. That will make 3, the 2, 3. So the now 1 will become 3. So 3 is still less than 5. Number 1 will become 4. And for one more time, it will be incremented and it will become 5. And then it will stop basically. Okay. Draw a flowchart which takes a string and prints true if its length is greater than 10 and false otherwise. How about this one? Again, I'm asking for a flowchart which takes a string and prints true if its length is greater than 10 and false otherwise. We have a small typo in there. We can fix that. And yes, this is going to be our last exercise in terms of flowcharts. And then as a last slide, I will have a riddle. And for that riddle, actually, as we're going to have 3 more hours today, we can give a 2 hours break. That will be all right. And I can give you some time for solving this last riddle. So I'm going to ask you to try to solve it for the 1 extra hour I will be giving it to you. Okay. So we will finish it right now. So just give me 5 more minutes so that I can present the riddle to you. And then we will go for, we will basically not do the 3rd hour, and there you will try to solve the riddle, if that's also okay with you. Instead of 2 hours break, can we finish 1 hour early and still do 1 hour break? I can ask that, but yeah, I can ask that. In that case, we would have finished early, right? That would be better, maybe. I can ask that. Okay, let me ask it right now, actually. Okay, yeah. If that's better for all of you, I can do that. Probably. Let me ask it, but maybe probably it doesn't fit for everybody, and the regular schedule is there. But let me ask it anyways. But right now, it is a 2 hours break. If there's an update, I will just inform you from the announcement channel. Okay. Let me speak to the team. Okay, I asked it. If there are any updates, I will just inform you. So any responses to this question? Do we have any solutions? A flowchart which takes a string and prints through if its length is greater than 10 and false otherwise. Again, I'm expecting you to do this with a loop and not using length method or something like that. If you do that, I mean, that's also okay, but the other one would be more advanced and a challenge. Semi printed the pseudocode version, but we were looking for a flowchart solution. If you have pen and papers or a tool where you can draw, in fact, there's a tool which you can draw diagrams. Let me do that with you. It's called Draw.io. You can also draw your shapes using this right here. Mina, the last hour, I will just finish it early right now, and the last hour will be for you to solve the riddle that I will be representing. So it will basically finish 1 hour early today. I asked the team if we can start the other session 1 hour early instead of doing 2 hours break. If that's possible, we will do that. If not, we will just skip it. Because maybe we won't have a consensus for doing that, right? Maybe some people are not available at that time and they want to do a break at that time. Okay. Okay, so we have a response from this again. Let me check that out. So it starts, you get a string, and then you check if length is 10. If length is 10, then true. If it's not 10, process count, letter. Okay, what is that process part? I didn't get it, Susan. That process part, no part. What does that do exactly?
Okay, actually, I didn't know how to connect to the main chart. So it counts the number of the letters in the process. And it should give false, right? Okay, I will redo that then. So it should give false then?
Yes, yeah, right there. I mean, yeah.
It doesn't have to return to the main chart if it's false, right?
If it is false, yes, exactly. It should just print no or false, as you did the other way as well. So if it is yes, true. If it is no, false. That's what you should do. And then both false and true should be connected to stop. Okay. So we should begin with a start here. Okay, this should say start inside it. Let me do that quickly. So this is start. And then we will be taking an input. So it's this box right here. Just put it there, and we have to connect them with this arrow right here. So it starts, and right after the start, I basically get an input, get letter, get words, let's say. And then So I will do the advanced version. Okay, I will do the loop first. Yeah, this is also correct. So Yusuf's solution is also correct. You can also check that one. What he does is he directly checks. He defines a variable called len, and we can understand that this is the length of the string that you're getting. But you also might have to indicate that another process, and in that process it says len gets length in brackets string or something like that. Okay, and then if the length is 10, if no, in that case it says false, and if it's yes, in that case it says true and then stops. But here I will do it with a loop. So I will basically be counting the amount of letters that are present in the word that I'm getting in here. So here I will have a condition box first. So we have an yes side, we have a diamond. So in here I will say if. So I will actually have a count in the beginning. Okay, I will make an assignment here. I get a word. I make an assignment, and count will be 0 in the beginning. So here I will be counting the amount of letters inside the word. Count is 0 in the beginning. And then I will have the decision box back. We will, at this point, we will say this. For we will use here. No, not actually for. If end of letter, let's say, if end of letter. If it is end of the letter, it will have another box here. And check if count is greater than 10 or not. And then we will have our print in there. Let me connect these two. So this is the no case. Sorry, this is the yes case in here. Okay, I have my yes case in here. Let me say yes in there. Where is the text box? Yes, right here. And I will say yes. So if it is end, I said letter, sorry, it should be word. Okay. If we have arrived at the end of the word, so that's the end of line, in other words, in the context of computers. If that's the case, I check if count is greater than 10 or not, and then I will say true or false at that point. But if this is no, so if I'm not at the end of the word, I'm not at the end of the line, what I will be doing is this. I will increment count in here, count plus plus, or I don't know, increase count. Okay, and then I will be going back to this one right here. Yeah, this arrow is probably better, right there. Okay, this is really painful. Yeah, but you got the idea, right? This arrow is going there. So before I make it even worse, let's just keep it like this. So if I'm at the end of the word, I check if count is greater than 10 or not. If I'm not at the end of word, so let's say no in here. If I'm not at the end of word, I increase count. And up until I am at the end of the word, I increase count. And as soon as it is yes, what I do is I check if, okay, why does it do like that? I was able to pick the arrows previously. Yes, like that. Okay. So if count is yes, it is going to be true. And if count is no, it is going to be false. Okay, so here I will say print true, and then I will say print false. And at the end, what will happen is basically it will end, right? Not this one, but the circle one, the ellipse one. Here it will stop. And that will be connected also. Like this. And there you go. Okay. Any questions on this? Except for this error right here. I should maybe fix that so that you don't get confused. Okay. Like this. There you go. Okay. Nope, it's clear, right? And also let me connect this as well. We have an empty space in there. And this is also connected. This is not needed, and this is not needed. There you go. This is the diagram for slides, this problem right here. Pseudocode easier than flowchart to use. Which one is popular? Definitely pseudocode is much more popular. In fact, flowchart is a little obsolete, but flowchart is looks better. Okay, it looks better. So if you have a really simple algorithm, you could use flowchart. But if it is really complex and big, in that case, flowchart would be a pain. But in this case, in these smaller problems, flowcharts look better. And for example, if you're going to explain it to a technical person, pseudocode is okay. But if the person you're trying to explain the algorithm to is not technical, probably flowcharts are going to be better, for example. Okay. Okay, so we've already exceeded the time I mentioned. So let me quickly give you the riddle and maybe take a screenshot of it and send it in the chat. And I will give you time, basically 2 hours now, for you to solve it. And here, we're going to be working on anagram words. And what do those mean? They mean they are the words that have the exact same letters rearranged. So they have the exact same letters, but in different orders. If this holds true, then these two words are anagrams, okay? And I'm asking you to use these steps of computational thinking and then explain how you use them to determine if these words are anagrams or not. You can also create an algorithm, or if you're already comfortable with Python, you can write a program that does this. But the more important thing that I'm expecting you to do is how did you use computational thinking to be able to understand if these are anagrams or not? And if you come up with an algorithm or a code, that will be even better. Okay. So think of this like a small homework for the next couple hours. At the beginning of the second session today, I will be asking you guys how many of you have completed it. In fact, you can actually, in these 2 hours, if you completed, you can send me the codes and your responses from DM so that we don't lose any time, and directly I will be able to present them to the other people in the class. Okay. So did I send the screenshot? No, I did not. Okay, Mina did it for me. Thank you very much. So there's the result. Okay, I'm expecting you guys to solve it. It is a little complex compared to the problems that we have solved today, but I believe that you guys can do it because you did pretty well today, also building the algorithms for other simpler problems. So this is the next step for you to accomplish.